Hi class. So today what we're going to do is we're going to set up problem 7.5 in your homework. And to do that, this is a pretty straightforward problem, but there are a couple of nuances in there that you need to be aware of. So first of all, what you're given is this. We're given 50 pounds mass of 60% dairy cream. What we're going to do with that is we're going to heat it. So we're going to heat first from 110 degrees F to 140 degrees F. And then the second part, we're going to check the same thing from 55 degrees F to 85 degrees F. So what we want to know, heat required, and why are the answers different? So the first thing that we need to do is we actually go to figure C2 in your text, and what you'll find in figure C2 is here's our dairy cream right here. And I'm going to go ahead and draw on here just to show you that line. And I'm a little bit off, but that's okay. So there's your dairy cream line, and what's interesting is that for the first part of the problem, what I'm asking you to do is I want you to look at it from this point right here to about this point right here. And what you'll notice is that it's linear in that range. It's not really changing a whole lot. So in that case, what you can do is you can make the assumption that C is equal to 0.7, and it's constant for the whole problem. Where it gets interesting is when we look at 55 degrees F to 85 degrees F, which is basically in this range right here. So if we look at that and we assume that C was a constant, what you would end up with is you would end up with a C that was here and here, but that doesn't work. So really what you have to do is break this problem down into two components, and you have to find an average C value from this point to this point, and another average C value from this point to this point. So let's go ahead and set this up a little bit for you. All right. The first thing that you know, let's assume that your kinetic energy and your potential energy are equal to 0. So you know how I talk about how do you have a big change in velocity, or do you have a big change in height or elevation? Our V term is not changing, so V1 equals V2. So in that case, that means that our kinetic energy is 0, and our pressure, and so as far as we know, is equal to P1, P2. So our potential energy change is also equal to 0. So that simplifies our energy equation a lot. So the next thing that we do then is let's look at conservation of mass. Does our mass change in this problem? It doesn't, so M in equals M out equals 50 pounds mass. So the next thing we can look at is conservation of energy. And in that case, Q equals E2, so our final state minus our initial state. And that's because we have a container with cream in it, and that container is being heated. So we're adding energy to the system. So really what we're trying to figure out here is what that change in energy is for these two temperature states, right? Okay, so let's take a quick look at that. Like I said, for heating from 110 to 140, we have this nice constant C value. So that one I'm not even going to mess with for you. In that case, because Q equals E2 minus E1 and delta E is equal to mass times delta U, and that is equal to mass times C, specific heat, times delta T. You ought to be able to figure that one out. Now we actually use this same equation to do the second part, which is the 55 to 85 portion of it. What you need to know for the 55 to 85 portion of it is that really what you're going to be doing is you're going to take an average of your C value between these 2 points and an average of your C value between those 2 points, and you just add those together. So you go back to this same basic equation, MC delta T. So we're going to call this QA, delta EA, QA again. Now for our B, QB is also equal to MC delta T, but now our C value is variable. So what you need to do is figure out C average between point A and point B, C average AB, and calculate, and C average BC and calculate, and then you'll be able to get to where you need to go. So here's my question for you. For the second part, why are the answers different? So here's a little hint. Ask yourself this question. Are lipids in cream uniform? In other words, do they all have the same chemical composition? And if they don't, could they be melting at different temperatures? And if they're melting at different temperatures, then how does that impact energy in the system? And think about state changes and enthalpy, and put your answer in those terms. So that's it. You guys should be able to do this. Good luck.